In this video, we are going to be looking at LDRs and thermistors. LDR stands for Light Dependent Resistor. On the left, we have the circuit symbol for an LDR, and the image on the right is a typical LDR. With an LDR, the resistance goes down as the light levels go up. We need to remember this for later on in this video. Let's see this on the graph below with resistance on the vertical axis and light level on horizontal axis going from dark to bright. A typical use of an LDR may be in a street lamp that turns on when the light levels fall below a certain level, such as at dusk. Thermistors change resistance as the temperature changes. On the left, we have the circuit symbol for a thermistor, and the image on the right is a typical thermistor. We need to remember that the resistance goes down as the temperature goes up. Let's see this on the graph below with resistance on the vertical axis and temperature on the horizontal axis going from cold to hot. A typical use of a thermistor would be in an air conditioning unit where it would activate when the temperature reaches a certain level, such as on a hot day. Let's now look at an example circuit using an LDR, light dependent resistor. On the left, we have the input PD or potential difference, the LDR itself, resistor. Finally, we have the output PD or potential difference. Now let us state what happens to the output PD as the light level gets higher. From previously in this video, we can recall that as light levels increase, the resistance of the LDR will decrease. In a series circuit, if we decrease the resistance of one component while keeping the resistance of the other constant, then the potential difference across it will decrease. As the total sum of the potential difference across the LDR and resistor must equal the input PD, then if the LDR has a lower resistance, hence lower potential difference across it, the potential difference across the resistor, hence output potential difference, must increase. Let's finish off this video by looking at a worked example question. So here in the dark, the LDR has a resistance of 20 ohms. When it is brighter, the resistance of the LDR decreases to 5 ohms. Work out the output PD in, first of all, A, the dark, and secondly, B, when it is brighter. In the dark, using equation V equals IR, where V is potential difference, I is current, and R is resistance. Since I, the current, is constant in a series circuit, then V is proportional to R. This means that as R increases, then so does V. We can work out output potential difference by using the resistance of the resistor divided by the total resistance of the circuit times the input potential difference, which is 10 divided by 10 plus 20 multiplied by 6, which gives us an output potential difference of 2 volts. When brighter, we just need to change the resistance of the LDR to 5 ohms, and that gives us an output potential difference of 4 volts. So output potential difference goes up as the resistance of the LDR goes down, since LDR has lower PD across it. Thank you very much for watching this video.